So today we'll be covering the diaphragm materials. And so to give you an overview, we'll cover the introduction to the AODD pumps, diaphragm failures, factors for selecting a diaphragm, application examples, and proven techniques as you get a takeaway from the whole presentation. So what is a AODD pump? AODD, which stands for air-operated double diaphragm, is a positive displacement pump operated by using compressed air. The diaphragm pump employs a pneumatic valve that directs compressed air back and forth between two sides of the pump. What are some benefits of using an AODD pump? AODD pump can handle a wide variety of fluid transfer application that is viscous, abrasive, and shear sensitive. It is one of the only pumps in the industry that can run dry and handle a deadheading. Also, it is a proven technology that is easy to use, reliable, and efficient. Now we'll show a video demonstration of the AODD.
This is a Wilden air-operated double diaphragm pump. How does it work? The liquid chambers are alternately filled and emptied by fluid that is drawn through a common inlet and discharged through a single outlet. The diaphragms in each chamber are linked by a single shaft, allowing them to move in unison. The air valve directs pressurized air to the back of diaphragm A. This begins chamber B's suction stroke, which starts as diaphragm B has moved toward the center of the pump, thereby creating a vacuum in chamber B. Atmospheric pressure then forces fluid into chamber B past the inlet ball valve. When the pressurized diaphragm A reaches the limit of its discharge stroke, the air valve redirects pressurized air to the back of diaphragm B. This begins the discharge stroke of chamber B. The hydraulic forces developed inside of chamber B force the inlet ball onto its seat and the discharge ball off its seat. This condition allows fluid to flow through the pump discharge. The same process occurs in the opposite chamber, constituting one full cycle. The pump will continue to run until inlet air supply is interrupted or discharge pressure rises to equal that of the air inlet pressure.
If you'd like to learn more about the AODD, we do have a pumps and system hosted a basics of AODD pumps and the technical advantages, and that webinar is available on pumps and system webinar website as well. This image is a semi-cutout view of the AODD pump, and today we will be taking a deep dive into the diaphragms, which is shown in the circle section of this image. So why is it important? The diaphragm is one of the critical parts within the AODD pump, which helps in moving fluid from the suction side to the discharge side. It is the single most common part that is routinely replaced. In the words of Andy Venegas, who's our application specialist that's been here and serving us for close to a couple of decades, diaphragm to a pump is like a car to a tire. And with that, we turn it over to the first poll questions.
Okay, so you should now all see a poll appearing on your screen. The question is, what powers the AODD pump? And we will give everyone about 30 seconds to answer. And here are the results. Michael and Jorge, do y'all have anything to add?
No, looks like everyone understood the assignment here. And yes, it is air operated.
Okay, great. So now we'll turn it over to Jorge for the next part of the presentation.
Thank you. Hello, everyone. My name is Jorge Hernandez. I am primarily focusing on the AODD pumps. So let me go ahead and begin here with the different diaphragm failures. We begin with the diaphragm failures because this is what will help us understand how material types and diaphragm designs can impact mean time between repairs. There are many different ways a diaphragm can fail. And just like a tire, we can make deductions based on the type of failure and application. Some common failures we can consider can be fluid compatibility, installation, valves, temperatures, media, and even solids. This is not a complete list of failures, and some failures may be unique to your application. However, we can deduce what has caused the failure through some of the pictures we'll cover in the next 2 slides. So we'll begin with the forced inlet pressure. That's going to be the image on the left. Forced inlet pressure can be caused by quick shutoff valves on the discharge side, causing the diaphragm to balloon and push further out than intended. Other side effects can be tearing and cracking. One potential solution to reduce force inlet pressure can be accomplished by installing a surge dam. The outer piston abrasion, the 2 images to the right, these can be due to at least 2 reasons: normal outer piston abrasion or abrasive media rubbing between piston and diaphragms. Normal outer piston abrasion is normal wear and tear, and requires a new diaphragm replacement. Abrasive material will naturally cause rupture between the piston and the diaphragm and cause a low an alternative solution may be installing an integrated piston diaphragm, which we'll cover a little later in our slides. Flex creases, that's the image to the left. Flex creases are part of the normal wear and tear conditions of a diaphragm. Cold temperatures can also exacerbate flex crease failures. Normal flex crease failures require new diaphragms, but if it is a cold temperature failure, then application may need to be revisited and a different diaphragm material may be required. High temperature and compatibility. These are other causes of diaphragm failures. Many AODD teams provide or offer a chemical compatibility guide online or in some downloadable format. You'll notice that each chem guide has a rating system. A rating system that will consist of multiple letters, A, B, C, and D, for example. It is recommended to choose an A-rated material for best compatibility and life of the diaphragm. Manuals also offer temperature limits for diaphragm design. Always refer to an AODD pump's manual for temperature limits to correctly pair the diaphragm material with the application temperature requirements. It is important to note that chem guides do not list all types of media, and if you find that your media is not listed, then I would encourage you to look at the containers the media is stored in, or the hose used to empty containers, for example, to make an educated decision on a matching diaphragm material type to your media. And next, we'll go ahead and move over to more poll questions here.
The second poll should be appearing on the screen now. The question is, what are 2 diaphragm failures? And again, we'll give everyone around 30 seconds to answer. And here are the results from that question. Presenters, do you have any comments?
Nope, those were the correct ones for the highest percentage there. So that looks good.
Okay, great.
Okay, next we're going to move over to failures from low quality diaphragms. So in other words, knockoff or pirated parts, however you would like to call it. Authentic OEM parts play a crucial part in increasing down between mean times repairs. It is tempting to save a couple dollars up front, but there is an increased risk for safety and premature failures when buying knockoff parts. Knockoff parts may not fit properly, not made of the advertised material, or they could have an inconsistent shape or thickness. Buying from a local distributor or directly from a manufacturer ensures you're purchasing an authentic OEM part. We do have white papers are available for additional information. So next we're going to look at a video showing the traditional diaphragm versus an IPD or integrated piston diaphragm, because we're going to get into the technology types and differences here in a minute. So we'll go ahead and play the video. So this portion here is showing the traditional diaphragm with your outer piston moving back and forth. You'll see the outer piston and the diaphragm. So you have the bead holding everything together. And then we have the IPD diaphragm. There is no outer piston. It's a over-molded diaphragm onto the outer piston. So here we'll see the general comparisons between the best option, which is the IPD diaphragm, compared to a traditional diaphragm. Okay, then moving on to here is the half cutout for both diaphragm designs, so we can take a closer look. On the left, the prevalent design, which is the traditional diaphragm design, and on the right is the evolution, the integrated piston diaphragm, or IPD diaphragm. The industry began with the traditional diaphragms located on the left. This design is offered as a TPE, PTFE, or rubber option. These traditional diaphragm designs, these were the pioneer for all AODD pumps. Then there came the evolution of the IPD diaphragms. These diaphragms are primarily made from TPE or PTFE elastomers. The evolution of the IPD diaphragm also opened the doors to the dairy industry. 3A certification is required, and only the IPD PTFE diaphragm offers such a solution for the dairy industry. Here we can see the diaphragms and pistons assembled. Again, note the outer piston on the left for the traditional, and on the right, we have the IPD with the over-molded elastomer onto the piston. There are more elastomeric options for the traditional, but when you reference the chemical guide, you'll notice overlapping compatibility between rubbers and TPE elastomers. You'll generally get better abrasion resistance with TPEs than you do with rubbers and PTFE. But choosing between TPE and rubbers can sometimes come down to your specific application. Additionally, there can be overlapping applications between TPE and PTFE elastomers, but you'll generally choose PTFE when the other two options are not available. Traditional diaphragms have been great for general use and food applications. But the IPD diaphragm continues to see usage where traditional diaphragms currently are. and in applications that traditional diaphragms cannot be used, either due to shear sensitive solids, large solids, or hygienic applications. Now, this graph represents a general overview of diaphragm life between traditional and IPDs. Values are generalized and may not reflect your specific conditions. Nevertheless, achieving mean time between repairs, it is crucial, which is crucial to our industry. We'll use the traditional diaphragm life as our base value. If we get 9 months worth of life, then the industry has seen up to 3 times longer diaphragm life for an IPD technology. Let's take, for example, making vaccines requires the use of eggs and disposing of the eggshells. But the eggshells can cause problems due to the shell's sharp edges. Traditional diaphragms have been used in this application, but the shells will naturally get trapped between the outer piston and the diaphragm, causing tear over time. A traditional diaphragm may only last a week, a couple weeks, month, maybe 2 months. But switching over to an IPD removes the entrapment points due to an outer piston exposed to the media, thus removing any shearing caused by the eggshells and increasing the maximum mean time between repairs. As you consider this graph and the life the technology can offer, sometimes all it takes is try something new and evolve to offer greater life and longevity to your application. Here we're going to take a look at diaphragm material types. So by this point, you've heard me say TPE, PTFE, and rubber. So what are those? Is there a difference? Yes, they are different. And the TPEs are a class of polymers or a physical mix of polymers, usually plastic and rubber, a plastic and rubber mixture. These are injected molded diaphragms. They provide a longer life due to the lack of fabric, because both are bonded at the molecular level. So there's no need for a fabric to hold and strengthen the diaphragm. So you'll get no delamination, you'll get excellent flex life, and great chemical abrasion. PTFE. PTFE is pressed out of a PTFE disc. PTFE is an incredibly versatile material with a wide variety of applications, though it's perhaps best known for its non-stick properties. You also have the full thickness of the diaphragm before it fails. Rubber. Rubber is one of the few naturally occurring polymers and prized for its high stretch ratio, resilience, and waterproof properties. Rubber was first used in diaphragms because that's what was available at the time, until the development of thermoplastic elastomers. Rubber diaphragms have a fabric typically made of a nylon material, and this nylon material is centered between 2 rubber diaphragms and then laminated together through a press. Less material available to use due to the need to include the fabric. And just like a tire's belt, once you reach the belt or fabric in the diaphragm, it is time to replace it. And as we continue to the diaphragm material types, as the industry continues to evolve from rubbers to TPEs and traditional to IPD diaphragm recommendations, we can see the elastomeric materials offered for each material type. This is not an extensive list of elastomer options, but they are the most commonly found or most popular in the industry. So what are diaphragm material types? How can we identify them? Some of these materials have synonyms for their names. Buna is also known as nitrile. FKM can also be called Viton. TPE Buna is also geolast. So you'll know some of these names by one name or another, or multiple names. Identifying your existing elastomer can be identified by their color. Rubbers are always black and available for the traditional style of diaphragm. Note that FKM or Viton is unique because it has a high temperature rating, great for high temperature applications. TPEs, TPEs can be a tone of beige, which can make it difficult to identify. So it may be necessary to reach out to your local part or pump specialist for further assistance. They come in traditional or IPD flavors, great abrasion resistance, and are generally a better selection over rubbers, similar applications. PTFE. PTFE is always white and offers the broadest chemical compatibility over rubber and TPE elastomers. These come in traditional or in IPD, good abrasion resistance, but its abrasion resistance is not as great as a TPE. Nevertheless, a really great overall option to go with PTFE. IPD material offerings are smaller, but an indicator on the direction the AODD industry is heading toward. So now we'll go ahead and move to our next poll questions.
Here is that third poll question, which is, what is the benefit of an IPD? And again, we'll give you all about 30 seconds to answer, and then we'll move to the results. And here are those results. Presenters, do y'all have any thoughts y'all would like to add?
Nope. Looks like everyone's still here and paying attention. That's good.
Okay, great.
Okay, next we're going to jump into application examples for different material types. So we'll identify different material types and diaphragm technologies typically found in common applications, exploring the applications portion for diaphragm material types and what type of elastomer and or technology you can find within each industry, and explore some examples for each application. You can find TPEs in ceramic applications, paintings and coatings applications. Either traditional or IPD diaphragms can be used in these two application examples. So let's explore some applications, and we'll jump in with ceramics. There are many unique stages of ceramic production. Among them are atomizing, electroplating, painting, water treatment, and press filtering, where the pump's ability to have the greatest mean time between failures makes the difference. Santoprene and polyurethane are most commonly used in ceramic applications, with either a traditional diaphragm or an IPD diaphragm. However, it would be best to use an IPD for those high abrasion processes for reliable operation and efficiency. Paintings and coatings. Titanium dioxide is used in paint slurries, and this slurry is highly abrasive. Santoprene diaphragms can be used to move titanium dioxide paint slurries in its manufacturing process. Transferring titanium dioxide using traditional diaphragms becomes a challenge, primarily due to the abrasion between the diaphragm and outer piston. Choosing an IPD would solve and remove the abrasiveness a traditional diaphragm would face due to its design. Although Santoprene is chemically compatible with titanium dioxide, the technology needed an upgrade. An upgrade to an IPD giving the greatest mean time between failures. We have great white papers on paints and coatings if you would like to learn more. Food, Beverages, pharmaceuticals, cosmetics, and many more industries are increasingly found using PTFE diaphragms and leaning more toward IPD diaphragms due to their broad range of FDA, 3A sanitary standards, USP Class 6, and EC 1935-2004 certifications. Additionally, FDA and hygienic industries choose IPDs due to their sanitary design and ease of cleanability. And a food and beverage application, we can see that PTFE can be found in many of these applications, but there are FDA hydro and FDA santoprene options that can also land in these common applications. As previously mentioned, there will be many overlapping options in elastomers and technology designs. However, the broad chemical compatibility you get from PTFE, you may find that PTFE is a one solution elastomer. Take, for example, soft drink production has multiple processes, from unloading flavoring, corn syrup, water, etc. A PTFE diaphragm covers all processes from unloading, batching, and mixing. Utilizing one common elastomer to tackle the strict protocols that can't be deviated when producing a soft drink, a PTFE IPD diaphragm is a great solution overall. Pharmaceuticals, these applications or industries, this application requires no entrapment points and ease of cleanability. An IPD diaphragm will meet both requirements. You don't have to worry about the outer piston getting in the way or causing any unnecessary abrasiveness to the diaphragm, causing early failures. There are high cost losses if product leaks, and an IPD can remove any unnecessary leak points. Lastly, rubbers can generally be found in oil and gas and mining applications. Mining has many complex and sometimes delicate operations that can't be performed, that must be performed properly if the mining operation is to perform at its highest level of efficiency. From mine dewatering, removing excess produced water from the mine is a critical to general service for common liquid handling applications. Product transfer comes in all forms in a mining operation, from loading and unloading from transport trucks with new and used oils for the heavy machinery, fresh and fouled water, and many other processes within the mining industry. You may find that rubbers can be used throughout the mining process to tackle all those loading and moving water. Oil and gas will use unloading jet fuel from a truck into a drum container or moving hydraulic oils. Rubbers can transfer your media from crude components into their final stages of consumed goods. The oil and gas industry can be a very harsh and complex industry with multiple production and transfer points along the supply chain. Rubber diaphragms can be a solution for a multitude of transfer points using a traditional design. And we will include these special applications portion with a reduced stroke. So what is a reduced stroke diaphragm? So on the bottom left on this slide, you'll see the diaphragm is not touching the wall of the liquid chamber. Right, so that is the liquid chamber in that black arrow. And then you have your diaphragm here with your outer piston. So you have all this light blue section is all of the media that's within the liquid chamber. So the diaphragm doesn't fully extend. So it's really great for like wine productions, for example, or latex paint is another example. However, you do get lower suction lift on the reduced strokes, and you get less displacement because you have all that excess liquid within the liquid chamber because the diaphragm doesn't fully stroke all the way to the wall of the pump. But you will get a really great flex life, decrease of abrasion, and you can do a large solids passage. So next, we'll go ahead and move over to the pole section.
And here is that final poll. The question is, what material type is generally used for hygienic applications? And for the last time, you'll have about 30 seconds to respond. And here are those results. Presenters, do you have any comments for this last question?
No, that is good. PTFE is correct.
Okay, great.
All right, so lastly, we're going to give you some proven techniques here that you can store in your back pocket, give you really good direction on what kind of diaphragms you want to look into. So typically a really good starting point is to start with your TPEs. Your TPE elastomers, they have really great compatibility, great life, and they're offered in the traditional and IPD designs. Rubbers, these you would use rubbers when TPEs are not available. And like we mentioned earlier, the major exception is going to be your FKM, and that would be due to the FKM's high temperature capabilities. The PTFE, these you would generally choose when TPE or rubber elastomers are not an option. PTFE will give you the widest chemical compatibility, in case you're not sure what kind of media you're working with, like proprietary liquids, and then also hygienic applications. These hygienic applications would require a PTFE. Next would be to reference your chemical compatibility guide, whether that's in an EOM or a online format. These will give you elastomers that are compatible with your specific media. And like we mentioned earlier, if something's not listed there, just talk to your local pump specialist to help you select a really good option for your specific application. Diaphragm Life. So what kind of a life do you want out of your diaphragm, right? And this could also be very application specific, because some applications are highly abrasive, so then you'll consider an IPD, something that's not highly abrasive, like just moving water or even chlorinated water. You could use a traditional diaphragm. Last but not least, reach out to your local pump or part specialist or the factory, and then they'll be more than happy to help you with your specific applications.